Assalamualaikum. So we continue our discussion in the topic of powder metallurgy process. This is the part 2. So we continue on the process of powder metallurgy. Before this, we have discussed the process. We have discussed the powder production, mixing, and compaction. So we continue, and the fourth process is a sintering process. So after the compaction process, the metal, the part from the removed from the die, we call it the green part. So it has retained its shape. It has a shape but lower strength. So in order to increase the strength of the part, the green part need to go the next process. We call it the sintering process. What happened in the sintering process? The metal powder is heated in a controlled atmosphere furnace to a temperature below its melting point, but sufficiently enough to allow the bonding between particles. The effect of the sintering, the compacted part will become brittle, and it will increase its strength. And then the secondary process, there is is a optional. Secondary process is optional and depend on the what type of the secondary process is required. So the main purpose is to increase the dimensional accuracy, and also we can apply the welding together to produce a more complex shape. The type of secondary process is coining, impregnation, infiltration, heat treatment, machining, and finishing. Coining is from the 6 secondary process. Here the most important is impregnation and infiltration. This is the unique process which we can only apply for the powder metallurgy part only. Other process such as coining we can apply from part which produced from many process. Also heat treatment, machining, and finishing. So here the unique process is impregnation and infiltration, which only can be used for the powder metallurgy part. Okay, for the coining is a sizing or repressing, and component or the product is placed in the die and then recompressed again to press the detail or to improve the dimensional accuracy. Okay, for impregnation is forcing oil or other liquid into the porous network. Okay, for the porous network, the compacted part or powder metallurgy part, it has the porous network. So it means that in the powder metallurgy part, if we look at very detail using the microscope, we can see the grain of the microstructure of the grain of the powder metallurgy part. There is a small pores, many pores inside the part. So that's why we call it porous network. The porous will be filled with the oil, which we force the oil to fill the porous area between particles, between the powder particle. It can be done by immerse the part in the bath and apply the pressure. So immerse the part into the oil, and then we increase the pressure oil. Okay, the advantage of impregnation, we can the product is a it is a self-lubricating oil, self-lubricating part, oil impregnated. So this is the unique properties of the part which we can produce using powder metallurgy, and then we apply impregnation. So the end product we can get such as gears or bearing which all impregnated, which mean that the part is a free maintenance, and it can increase the life of the part. Other secondary process is infiltration. Infiltration is also unique process which we can only apply in the powder metallurgy part, which where the porous network, the porous area is filled with the lower melting metal. So differ from the impregnation, we fill it the porous network with the oil. For the infiltration, the porous network is filled with the metal. The metal must have a lower melting point than the powdered part. Okay, the advantage of the infiltration is improve the hardness. We can improve the hardness and strength of the part. And the pores are filled, thus venting moisture penetration, which cause corrosion. So other advantage is we can prevent the corrosion. Other process is a heat treatment to increase the strength, machining to improve the surface or the size, and finishing such as deburring finishing is also used to improve the surface of the part. Okay, this figure show the diagram of the process in powder metallurgy. We start with the powder, and then mixing process, and then compaction or pressing, and then goes to the sintering process to improve the strength, and then goes to the final step is a secondary operation. And after that we can get the final part. Okay, the advantage of powder metallurgy, we can produce a near net shape, eliminate and reducing the secondary process, and if we compare to the forging process, this is the process is a much simple, because not much step in pressing process. Okay, for the forging, we have to press so many times. So there is stages in the compaction process for the forging. And then the other advantage is a very little waste of material produced. And then other than that, we can get the porous product. So the porous product is can be used to produce a product used as a filter. Filter lubrication, gas and liquid filtration, and then it can be used to fabricate the metal which has the high melting temperature, such as tungsten. So tungsten is a high melting temperature. We can shape the tungsten material using casting. Yes, we can, but it requires high energy, a lot of energy to melt the tungsten. So the best way is to form the metal, tungsten in form of metal, and then compress, put it in the furnace to allow for sintering process. Okay. Also, the dimensional accuracy also is good. The surface finish also good for the powder metallurgy. and process can be automated with more economical production. The disadvantage of powder metallurgy is a high tooling cost, expensive metallic powder. Okay, difficult to store the metal powder because metal powder is very hazardous, fire hazardous. Limitation on the part geometry is if the product which need to produce is very complex, it is not possible to produce using powder metallurgy. And variation of metal density. So the last disadvantage of powder metallurgy may happen if the blending and mixing is not done properly. Okay, so this is the design capability or rule to design the powder metallurgy part. So you can see the right side is a very good design, the left is a poor design. So try to eliminate the poor design and move to the good design. So such as we avoid the sharp corner, and then you use the fillet radius. Here also sharp radius, we use a fillet, and then also need to machine if the product require the hole. So the hole we done in the secondary operation, which we machine the hole. Okay, also the thread we can done in the secondary operation. Okay, thank you very much for these lectures. I will continue for the next forming process. Thank you very much.